and a very good day, everyone. I'm Hee Chun Hao from Group 3. Today, we are going to study about the Toshiba air conditioning energy efficiency. So this is our group assignment. So our group have 4 persons, which is me, Muhammad Haziq, Muhammad Azri, and Muntasir Awad.
Assalamu alaikum, good evening. My name is Muntasir Awad. My matric number AE 2099 from group 3. Now we will present the introduction. Numerical method are ways for solving mathematical problem in engineering analysis that are difficult or impossible to solve using analytical method. Uh, Such as those used in this assignment. We will be applied to employ some of those numerical approaches throughout this assignment, which will help engineers to not only solve numerous mathematical problem, but also to eliminate the requirement for many hypotheses and idealization of this circumstances. Okay, and in this chapter presents that gathered for a brand new Toshiba product called SMMS 7. The sense of calling the value of the full load energy efficiency rate comparison between the previous model and the current model of air conditioner was greater. This assignment we are using two methods that calculate the data are Lagrange and interpolation and Newton divided difference. Okay, and thank you.
Hi, Assalamualaikum. My name is Mohammad alias my matric number CE200059. So today I will explain on our methodology. So the language interpolation method is the first one we utilize. The technique of approximating a function of fx and guessing the missing function value over the interval a, b is known as interpolation. We employ quadratic approximation of the language interpolating polynomial that passes through 5 locations based on the data provided. So here is the formula of the language on the left side here. And the second method we use is the Newton's divided difference. Newton's divided difference interpolation formula is an interpolation technique used when the interval difference is not the same for all sequences of values, as we can see from this table. So the integral of 0, 1, 2 until 4, and the yield, and the formula of f1, f11, f12, and f13, and f14. So here are the formulas. The first Newton's divided difference is calculated as below this one. The second, the third, and the final one is the fourth Newton divided difference. Hence, this is the solution. So that's all from me. Thank you and Assalamualaikum.
So I'm going to talk about the manual calculation for this group project. In this group project, we have two methods to determine the 17 horsepower of the air condition for the full load energy efficiency ratio. So the first method is the Lagrange interpolation method. For Lagrange interpolation method, we have 4 steps, which is linear, quadratic, cubic, and quartic. So each of these methods have the disadvantage and also advantage. So first, we're going to look for this linear approximation. So since this linear approximation is only taking the first 2 latest data, so the approximate value for this method is considered as less accurate. The most accurate value for this Lagrange interpolation method is actually quartic approximation. This is because quartic approximation consider five of the latest value, and it can be summed together, so it will get the most accurate value. Next is the Newton divided difference interpolation method. For this method, it is highly recommended to have a table based on the data given, and the calculation is simpler than Lagrange interpolation method, but it is very tricky since it has so many decimal value. So let's see for the first level of this Newton divided difference. This is the first level, second level, third level, fourth level, and last level over here. This level can differ, depends on the data given. So in this manual calculation, we got the final value is 3.3076. So this proves that the Newton divided difference with Lagrange interpolation is actually we're having the same answer, and both of these can be used in approximation for 17 horsepower of air condition, but it's full load energy efficiency.
Hello and Assalamualaikum. So I'm going to demonstrate to you about the simulation method for Lagrange interpolation and Newton divided difference for our numerical method assignment. So in the first, the table below shows the data that we contain from the Toshiba catalog. So this is the data for X and Y parameter, which is horsepower versus full load EER. So for Lagrange interpolation method, we are required to find the horsepower for 17, which is between 16 and 18. So by using linear approximation and you input the formula from here, use the formula X minus B, A minus B times Y, and this X minus C and A minus C times B minus C times Y from the table over here. So you will get 3.455 somethings, which is logic, because between 16 and 80 horsepower, we get 3.31 and 3.60. So for linear approximation, it's also logic. So we go to the quadratic approximation and input the same formula by using the software. Input the Y parameters and the X parameters inside the software, and we calculate, we will get 3.3975, which is also logic, which is the value is also between 3.31 and 3.60. And we go to the cubic approximation, which is quite longer. You will see the same formula, and when we calculate the formula for A, B, C, D parameter and X, Y, you will get 3.363. The value of horsepower for between 16 and 18, which is 17 horsepower, we will get 3.363, which is also logical, and it is between 3.31 and 3.60. And for quartic approximation, which is we set as X to the power of 4, and we will get 3.3295 for the value. Input all the Y value to the formula A, B, C, D, E, X and Y parameter. So we get 3.3295, which is also logical, 16 and 18. So that is for the Lagrange interpolation for software method. So the next method are the Newton divided difference for simulation method. So for your Newton divided difference, they also are quite different, but it is also a method for interpolation in numerical method. So this is the table for horsepower, as you can see from the Toshiba catalog, and the Newton divided difference method. So you need to calculate one by one actually to get the value inside this table. So this is the calculation. It is a fractional. It is just a subtraction and involve fraction. So you can calculate it using the software. You just input the value and it will automatically display the value. So what I want to highlight here is how do you input inside Maple is, you can see actually how do we get 9 here. It is actually 17 minus 8. So that's why you get 9. So you just do long multiplication, 17 minus 10, that's why you get 7, you times, and the final answer for 17 horsepower for full load EER, you will get at 17 horsepower in Newton divided difference method, you will get full load EER is equal to 3.3076, which is logical. Because why? It is between 3.31 and 3.60 over here. It is different. It is between, the value is in between 3.31 and 3.60 for 17 horsepower. So which is the best method? Actually, both method, I think Lagrange interpolation method is the best method for software, because you can see the value is vary, and it is included between 16 and 18 and not too far, and the value is logical for interpolation. While Newton divided difference, you can see 3.31. If you round off, you will get 3.31, which is much more accurate, but the value is not too we call very not multivariable, versatile. So actually the value of the horsepower 3.31 is like near to 16. So that's why I choose Lagrange interpolation method is the best for solving our data for Toshiba catalog to find the horsepower for at 17. So that's it from me. Thank you.